Welcome everyone. In this video, we will learn about capped collections in MongoDB. A capped collection is a special type of collection that has fixed storage space. Unlike a normal collection, its size cannot grow indefinitely. When the allocated storage space becomes full, MongoDB automatically removes the oldest documents and inserts the new ones. This follows first in first out principle, similar to a circular queue. Because of this behavior, capped collections are ideal for applications where we are interested only in the most recent data, such as application logs, event logs, monitoring data, and sensor readings. Now, let us create a capped collection. So the syntax is db dot create collection method. Inside the method, we need to pass two arguments. The first argument indicates the collection name. In this example, the capped collection name is capped COLL. And for second argument, we need to give two parameters. We need to pass it as an object. That is, first one is capped true. So this capped true indicates that we are going to create a collection which is of type capped. And then second one, size 10,000. So this size parameter specifies the maximum storage space allocated for the collection. It is measured in bytes and not in the number of documents. In this example, the collection is allocated 10,000 bytes or approximately 10 kilobytes. And in the second example, we have given an additional field called max 100. So we can also specify maximum number of documents using the max option. So it indicates the number of documents that can be fit within the space. So the collection has a limit of second collection has a limit of 10,000 bytes and can store a maximum of 100 documents. MongoDB removes the oldest documents whenever either the storage limit or the document limit is reached. Next, benefits of capped collection. First one is insertion order reserved. So this makes capped collections very useful for storing log data because the oldest data appears first and the newest data appears last. So there is no need for sorting or indexing based on timestamp field. Since the documents are already sorted in chronological order, we can simply execute a find query to retrieve them. We usually do not need to sort the documents using the timestamp field. This improves query performance because MongoDB can directly read the documents in the insertion order. Next benefit is on-disk order maintained. MongoDB stores the documents sequentially on disk in the same order in which they are inserted. Sequential reading from disk is faster than reading randomly located documents. Therefore, capped collections provide faster read performance for sequential data. So this avoids no, no relocation overhead. Okay. And then finally, automatic removal of old data. So when the collection becomes full, MongoDB automatically removes the oldest documents. We do not need to write separate code to delete old records. This reduces application complexity and maintenance effort. Next, updating documents in capped collection. In a normal collection, MongoDB can freely move documents. Suppose we have three documents, document A, document B, and document C. If document B is updated and becomes larger, MongoDB can relocate it to another storage location. So the order may become document A and then an empty space, document C, and finally document B at new location. Since Normal collections allow document relocation, larger updates are not a problem. However, this is not allowed in capped collections. Capped collections preserve the physical insertion order. MongoDB cannot move documents to another location because that would break the sequential storage order. If an update increases the document size beyond the available space, MongoDB rejects the update. In other words, updates are allowed only if the updated document still fits within its existing allocated storage. For example, here is an insertion insert command. So the messages server started. If you want to try to update this message with a much longer message, for example, instead of server started, I'm going to update it as server started successfully at 10:30 p.m. So this is not allowed. Okay. So here the update may get failed. The reason is it is MongoDB collection capped collection is of fixed size, and if you are giving an update which is larger than the existing message, then it will fail the update. Since the physical order must remain unchanged, the MongoDB cannot move the document as well to a new location for update purpose. At the same time, if you are having an update like this, in the first, initially we are having the messages server started. If I'm updating the messages server running, this will get successfully updated. So if the message is same size or if it is smaller, then the update will be successful. Only if the size is larger than the current value, the update gets failed. Limitations of capped collection. First one is no document deletion. So we cannot delete individual documents. That is separately we cannot delete each and every document. By default, the the initially stored document will get deleted automatically. Okay. And the second one is size constraint on update. So once a collection has been created, we cannot increase or decrement the collection size and also the document size. That is fixed size. While creating the collection itself, we must predefine the size. Either we have to give it in bytes or we can give it in number of documents. We cannot extend the size beyond that. So MongoDB is not suitable for applications requiring frequent update. Also, they are not suitable for long-term storage data because older documents are removed continuously. So when to use capped collections? So let us see where capped collections are commonly used. They are best suited for applications that continuously generate new data while only the latest information is important. Examples include rolling transaction logs, application and server logs, monitoring systems, event streams, IoT sensor readings, message queues, and time series snapshots where only the latest readings are required. On the other hand, we should avoid capped collections when data must be stored permanently. Applications such as student database, banking systems, hospital records, e-commerce websites. So these require long-term storage and frequent updates. So for such applications, normal collections are better choice.